Let us see the solutions for lecture in electronics engineering, Kerala Public Service Commission. The examination held on 2017 December 2017. In this question paper, question 1 to 10 are related to general studies. From question 11 to 20 are related to mathematics. From question 21 to 2050 are electronics questions. So let us see the first question. Who launched Kudumbasri programs in Kerala? So it is Atal Bihari Vajpayee, the Prime Minister of India, launched this program in 1998 in Kerala. It was a poverty elevation and women empowerment program, and this program aims to improve the lives of poor women in rural as well as urban areas. So correct option is A. Next question. Who is the Governor General of India responsible for the appointment of Hunter Commission, the first Indian Education Commission on 3rd February 1882? Correct option is C. Lord Ripon. The first Hunter Commission was established by Lord Ripon in 1882, and this committee was appointed by the British government to investigate the education and Jallianwala Bagh massacre. The second Hunter Commission was established in 1919, and report was submitted in May 26, 1920. Who established Pratyaksha Raksha Daiva Sabha in 1909? So that is Poikal Yohanan. He, is, he founded PRDS Pratyaksha Raksha Daiva Sabha in 1909 in Kerala. Next question. Which Travancore ruler proclaimed the historic temple entry proclamation on 1936? Sri C. Balarama Varma of Travancore made the temple entry proclamation in November 12, 1936, and this proclamation abolished the ban on backward and marginalized communities from entering Hindu temples in princely state of Travancore. Correct option is D. Who was the founder of Malayalam journalism? Kunjira Menon is known as father of Malayalam journalism. Kunjirama Menon is known as father of Malayalam journalism. He was a journalist and founder of first Malayalam newspaper, Kerala Patrika in 1884, who was known as Kerala Kalidasan. So that is Varma Walia Koil Tampuran is known as Kalidasan. He was a poet and writer, formerly known as Kalidas of Kerala, because for his Malayalam translations for the works of Kalidasa. Correct option is D. Who was the founder and editor general of Srimati? Anna Chandani was a founder and editor of the journal called Srimati. Who wrote biography of Kanniram Kinavum? So that is D. V.T. Bhatta Tripad, who was famous for his question, the whole universe is in one mind. For his quotation, the whole universe is in one mind. Between mind and mind, there is no vacuum. It was quoted by Chattampi Swamikal, the Hindu sage and a social reformer. Chattampi Swamikal, who was a which was the highest literacy award in Kerala, that is Echutanan Chanan Award. This Chanan Puruskaram is the highest literacy award in Kerala, and this award is named after this person, Tunchattu Ethuchanan. It was given by Kerala Sahitya Academy, the state highest literacy award. Jnanapith Award is India's highest literacy award. Next question. So from question 11 to 20 are related to mathematics. Given x minus y is minus 1, z is 4, and 2x minus y is 0, w is equal to 5. These are the equations given, and we need to find the value of x plus y by z minus w. We need to find this value. So what is the value of x plus y divided by z minus w? So from this, z is equal to 4 and w is 5. We need to calculate the value of x and y. So from above equations, x minus y is minus 1 and 2x minus y is 0. So on solving, we will get minus x is equal to minus 1, x is equal to 1. So substitute x is equal to 1 here. X minus y is equal to minus 1, minus y is equal to minus 1 minus x minus 1 that is minus 2 minus y is equal to minus 2. So therefore y is equal to 2. The value of x is equal to 1 and y is equal to 2. That is x plus y, that is 1 plus 2 is 3. 3 by minus 1. So its value is minus 3. Correct option is B. Correct option is C. It is minus 3. Next question number 12. If Aij is a cofactor of an element, small aij of the determinant matrix is given, then the value of A32 is. So how to find the cofactor of a matrix? Let A be an n by n matrix. In a matrix, a cofactor is a number that is calculated by removing the row and column from a given element. The cofactor is then multiplied either plus 1 or minus 1 depending on the element position in the matrix. For this element A32, so that is C32, I is 3, J is equal to 2. So third row, second column. So this is third row, second column. For this element 5, we need to find the cofactor. That is 3 is equal to C32 is equal to minus 1 of 3 plus 2 I plus j, determinant of A32. So A32 matrix is obtained by removing this row and this column. So that is 2, 5, 6 and 4. So this is A32 determinant. So its value is 4 2s are 8 minus 6 5s are 30. So minus 22. So correct option is minus 1 power 5 into minus 22. Its value is 22. In the question they asked element value multiplied with cofactor value. So element value is A32. So element value is 5. Element value is 5 and cofactor C32, its value is 22. The product of these two is 110. The correct option is 1. A32 is minor here and C32 is cofactor value. In the question they have given cofactor multiplied with the element. So correct option is A. Next question. The fourth term of the expression 3x minus 1 by 3x whole power 6 is. So given expression is 3x minus 1 by 3x whole power 6. So the general term for the expression a plus b whole power n is tr plus 1 is equal to ncr a power n minus r multiplied with b power r. Here a value is, here a is 3x, b is minus 1 by 3x and n value is 6. Now in the question they have asked to calculate the value of fourth term. So T4 is T3 plus 1, that is NC, n value is 6, 6C 3 a power r 3x whole power n minus r 6 minus 3 b power r, b is 1 minus 3x whole power r value is 3. On substitution NCR is 6 factorial by n factorial by n factorial minus r factorial, n minus r factorial. So that is 6 factorial by 3 factorial into 3 factorial multiplied with 3 cube x cube minus 1 by 3 whole cube into 1 by x cube. On substitution its value is minus 20. The value of fourth term is minus 20. So NCR is n factorial by n minus r factorial into r factorial. So this is a formula. The correct option is option B. So option B. Next question. If a plus b is 45 degree, then the value of 1 plus tan a into 1 plus tan b is given. A plus b is equal to 45 degree. Apply tan on both sides. Tan a plus b is equal to tan 45 degrees. So tan 45 degrees is 1. Tan a plus b can be written as tan a plus tan b divided by 1 minus tan a 1 minus tan a into tan b is equal to 1. Now tan a plus tan b is equal to 1 minus tan a into tan b. So rearrange this expression. Tan a plus tan b plus tan a tan b is equal to 1. Add 1 on both sides. Now 1 plus tan a plus tan b plus 1. 1 plus this expression is 1 plus tan a into 1 plus tan b is equal to 2. Take 1 plus tan a common. So from this take 1 plus tan a common. So tan b into 1 plus tan a, that is 1 plus tan a into 1 plus tan b is equal to 2. The correct option is D. Next question. The acute angle between the lines. Given lines are, the acute angle between the lines is given as theta is equal to tan inverse m1 minus m2 by m1 plus m1 m2. m1 and m2 are the slopes of the lines. Given line 3x plus y is minus 7 is equal to 0. Slope of the line can be written as y is equal to mx plus c, where m is the slope of the line. Arrange the expression in this form. Y is equal to minus 3x plus 7. Here the slope m1 is minus 3 and second line is x plus 2y plus 9 is equal to 0. 2y is equal to minus x minus 9. Y is equal to minus 1 by 2x minus 4.5. Here slope m2 is 0.5 minus 0.5. Now the tan theta is m1 minus m2. m1 is minus 3 modulus of m1 minus m2. So minus 3 minus 1 by 2 divided by 1 minus 1 plus m1 m2. So m1 is minus 3, m2 is minus 1 by 2. On calculation, its value is minus 2.5 divided by 1 plus 3 by 2, that is 1.5 minus 2.5 by 2.5. So its value is 1. Tan theta is 1. Angle between the lines theta is equal to tan inverse 1, that is 45 degrees. So correct option is A, 45 degrees. Next question. Given limit extends to 2, x root 2 minus 2 root 2 by x minus 2 is. So substitute x is equal to 2 here. 2 root 2 minus 2 root 2 by 2 minus 2. So numerator is 0, denominator is 0, limit doesn't exist. apply L'Hospital rule. So that is limit extends to 0. Differentiate the numerator separately and denominator separately. So x root 2 is x root x is x power 1, x power 1 by 2, x power 3 by 2. So d by dx of x power n is n into x power n minus 1. So x power 3 by 2, that is 3 by 2 into x power 3 by 2 minus 1, x power 1 by 2. Limit extends to 2 and d by dx of constant, some constant k is 0, d by dx of 1 is 1. Now limit extends to 2, x root 2 d by dx of numerator, its value is 3 by 2 root x minus 0 by 1 minus 0. Now substitute x is equal to 2, 3 by 2 root 2, that is 3 by root 2. This is the value for the limit. 3 by square root of 2. Correct option is B. 3 by square root of 2. Correct option is B. Next question. The equation of the normal to the curve. X is equal to 2t, y is equal to 2 by t. Given x is 2t, y is equal to 2 by t. So from this, t is equal to 2 by y. Substitute in x. This is given. X is equal to 2 into t. T value is y, that is 4 by y. So from this, y is equal to 4 by x. So d by dy by dx, that is slope. Slope m is equal to dy by dx is equal to minus 4 by x square, because d by dx of 1 by x, its value is minus 1 by x square. Now substitute t is equal to 1, x is equal to 2t, for t is equal to 1, x value is 2. Similarly, y is equal to 2 by t, for t is equal to 1, y value is 2. X value is 2 and y value is y value is also 2. The point x comma y is 2 comma 2. Now slope of normal is equal to minus 1 by slope of tangent, that is minus 1 by slope of tangent, that is m minus 4 by x square. X value is 2, 2 square is 4, its slope is minus 1. Slope of normal is equal to minus 1 by slope of tangent, that is minus 1 by minus 1. So its value is 1. Slope of normal is 1. So equation of line is y minus y1 is equal to m into x minus x1. So y1 point is x, y1 x1 comma y1 is a point, y minus y1 is 2, slope is 1, x minus x1. So that is y minus 2 is equal to x minus 2. So from this, equation of line is y is equal to x, or x is equal to y, or x minus y is equal to 0. This is the equation for the line normal. So that is x is equal to y. Next question. Integral of 2x power 4 divided by 1 plus x power 10 into dx is. So let us assume we need to calculate the value of integral. So let us assume x power 5 is equal to some t. Now differentiate 5 into d by dx of x power n is n into x power n minus 1. So that is 5 into x power 4 dx is dt. Next, substitute x power 5 is equal to t in the given expression. X power 4 into dx is dt by 5. So that is dt by 5 integral 1 by 1 plus t square. So it is 1 by 5 dt by 1 plus t square. So 1 by 5. We know that integral 1 by 1 plus x square dx is equal to tan inverse x plus c. So apply this formula. So from this 1 by 5, already 2 is here. So that is 2 by 1 plus t square, 2 by 5. It is 2 by 5 tan inverse t plus c. So t is x power 5, 2 by 5 tan inverse x power 5 plus c. So this is the value of given integral. Correct option is C, 2 by 5 tan inverse x power 5 plus c. Next, the area included between one arc of the curve y is equal to sin x and the x-axis is. So between one arc of the curve and x-axis. So this is the area we need to calculate. This is the x-axis. So we need to calculate this area. So area is integral 0 to pi sin x dx. So integral sin x is minus cos x, and the limits of integration is from 0 to pi. So minus of cos pi minus cos 0. So that is minus cos 180 degrees is minus 1, cos 0 is 1. So area is 2 units. Correct option is B, 2 square units. 19th correct option is B. Next, question number 20. The solution of dy by dx. So given expression is dy by dx plus 2x by 1 plus x square into y is equal to 1 by 1 plus x square. This is a given linear first order linear differential equation. So this expression is in the form dy by dx is equal to dy by dx plus p of x into y is equal to q of x. Here p and q are the functions of x. P of x is 2x by 1 plus x square, and q of x is equal to 1 by 1 plus x square. The solutions for this linear differential equation is, general solution is y into integrating factor is equal to integral q into integrating factor plus c, where integrating factor is e power integral p dx, p of x into dx. So let us calculate the integrating factor first. So integrating factor is e power integral p. P of x is 2 of x by 1 plus x square into dx. So that is integral 2x by 1 plus x square dx. We need to calculate the value. So let us assume x square is equal to t. So this expression will become 2x dx is equal to dt, that is dt by 1 plus t. Integral dt by 1 plus t. Integral 1 by x is log x, that is 1 plus t. Logarithm of x, t value is 1 plus x square. E power integral of 2x by 1 plus x square is equal to logarithm of 1 plus x square. So its value is 1 plus x square log e base e. It is natural logarithm ln natural logarithm e base e, that is 1 plus x square. So this is the value of integrating factor. Now general solution is y into integrating factor 1 plus x square integral q. The value of q is 1 by 1 plus x square. This is the value of q. 1 by 1 plus x square into integrating factor 1 plus x square plus c. So that is integral dx plus c. So its value is x plus c. So y into 1 plus x square. Y into 1 plus x square is equal to x plus c. Now the solution is y is equal to x plus c by 1 plus x square. This is a solution for the given differential equation. Correct option is D, x plus c by 1 plus x square. X plus c by 1 plus x square is a given solution for the is a solution for the given first order linear differential equation dy by dx plus 2x by 1 plus x square into y is equal to 1 by 1 plus x square. And this is the formula to calculate the integral factor, and general solution is this: y into integrating factor is integral q into integrating factor plus c. This is general solution for given differential equation dy by dx plus p of x into y is equal to q of x. Next question. So dash is an amplifier commonly used as a frequency multiplier. So which amplifier, in the question they have asked which amplifier is commonly used as a frequency multiplier. So class C amplifier, class C power amplifier is commonly used as a frequency multiplier due to its inherently nonlinear characteristics, which allows it to generate the harmonic frequencies which are properly designed and tuned with the resonant circuit to select the desired harmonic or desired frequency for amplification. So it is a class C amplifier which exhibits maximum distortion, and the Q point is below the x-axis, that is VCE axis, and it having the efficiency of 90% and conduction angle is less than 180 degrees. So correct answer is class C power amplifier is commonly used as a frequency multiplier. In the given table, so different conduction angles for class A, class B, class C amplifiers are given. For class A it is 360 degrees, for class B it is 180 degrees. So for class AB, conduction angle is between 180 and 360. For class C power amplifier, conduction angle is less than 180 degrees, and efficiency is maximum for class C power amplifier, that is 95%. Here Q point is below the x-axis, and it exhibits this class A power amplifier has maximum distortion, whereas no distortion in class A power amplifier. Next question. Removing bypass capacitor across the emitter leg resistor in a CE amplifier causes. Removing bypass capacitor across the emitter in CE amplifier will reduce the voltage gain because of negative feedback. So voltage gain is due to increase in negative feedback. If that emitter resistor is removed, then it causes a negative feedback. So negative feedback decreases the voltage gain through the emitter resistor. So if voltage gain is decreased, obviously the amplification is also decreased. So in CE amplifier, if bypass capacitor across the emitter resistor, that is common emitter amplifier, emitter terminal is connected to ground, and this is resistor, and there is a capacitor here. This resistor is emitter resistor, and this is capacitor connected across the emitter resistor. Resistor RC, voltage divided by S, R1 and R2. This is base, collector, emitter. Now, if this CE capacitor is removed, it causes negative feedback from output to input. Because of negative feedback, voltage gain is decreased, amplification is decreased. Therefore, the correct option is D, which decreases the voltage gain. Next question. If the maximum collector current due to signal alone is 3 milliamperes, then zero signal collector current should be at least equal to. So it should be at least equal to 3 milliamperes. So because in CE amplifier, zero signal collector current, that is DC current, DC collector current should be at least equal to maximum collector current due to signal plus quiescent current. So here zero signal collector current, that is quiescent current is a DC collector current when no input signal is applied. So the correct option is 3. So the zero signal collector current is maximum collector current due to signal plus quiescent current. So quiescent current is, suppose assume quiescent current is 0. So then zero signal current must be at least equal to, that is 3 milliampere. Must be at least equal to maximum collector current, that is 3 milliamperes. Correct option is C. Next question. In multi-stage amplifier, the overall frequency response is determined by. So the overall frequency response of a multi-stage amplifier is determined by frequency response of each individual stages. The frequency response of each individual stage, because when stages are cascaded, the gain at any frequency is essentially the product of gains of individual stages at that particular frequency. Correct option is A. So frequency response of each stage depending on the relations of critical frequencies. In multi-stage amplifier, the overall frequency is determined by frequency response of all the stages, all the individual stages, depending upon the relation between the critical frequencies. The overall frequency of multi-stage amplifier is directly determined by the frequency response of individual stages within it, with critical frequencies of each stage significantly impacting the combined frequency response. That is, bandwidth and roll-off of entire amplifier, that is cascaded amplifier, are heavily influenced by individual stage limitations at higher and lower frequencies. Next question. So correct option is A. Next question. Having the power corresponds to 3 dB, halving the power, that is half power means. So half power means the power is reduced to exactly half of its maximum value. So half power frequency corresponds to 3 dB decrease. 3 dB decrease. So half power frequencies are 3 dB lower, or 1 by root 2 times of half power frequencies, or half power is half of the maximum power at 3 dB. At 3 dB power is half of the maximum power, and at 3 dB voltage is voltage at 3 dB is Power is half of maximum power, and voltage is 1 by root 2 times of maximum voltage, or 0.707 times of maximum voltage. So current is also 0.707 times of maximum current. At 3 dB, current is 1 by root 2 times of I maximum. At 3 dB, power is half of the maximum power, voltage is 1 by root 2, and current is 1 by root 2. So this is halving the power corresponds to 3 dB decrease. Correct option is B, 3 dB decrease. 3 dB decrease. Next question. If negative feedback is introduced in an amplifier with shunt current configuration, the input resistance will be. This shunt current configuration or shunt series feedback, that is current controlled current source, current controlled current source. Your input is current, output is current, output sampling, that is current sampling, input mixing, that is current mixing. Hence it is a current controlled current source. For this current controlled current source, input resistance decreases, output resistance increases. So example for this shunt current feedback or shunt series feedback or a current controlled current source is cascading amplifier. In the question they have asked about input resistance. Input resistance is decreased, output resistance increases. Correct option is D. Next question. Pinch off voltage of an FET. There are two definitions for pinch off. One is the drain to source voltage, after which drain current is constant, that is JFET enters into saturation. Another definition is the value of VGS at which the current below drain to source voltage can no longer flows. For further any value of VDS, one pinch off in saturation region, other pinch off in cutoff region. This is a pinch off point in saturation region because for VGS is 0, when VDS is equal to VP, this drain to source voltage is equal to pinch off voltage, then drain current ID is equal to IDSS. Hence, beyond this, if VDS is increased, beyond this point, beyond the pinch off voltage, if VDS is increased, drain current remains constant. Hence, it is a constant current source. JFET acts like a constant current source. So, one more definition for pinch off is when VGS is equal to pinch off voltage, the drain current will become 0. Even if VDS is increased, the drain current is 0. This is one more pinch off region. There are two definitions for pinch off voltage. In the question, all free charges are removed from the channel, that is drain current is 0. So pinch off voltage of an FET is a drain voltage at which all free charge carriers get removed from the channel. Correct option is C. Next, so these are the characteristics of N channel JFET, and these are the characteristics for P channel JFET. When VGS is equal to pinch off VGS is equal to VP, the drain current will become 0. Even if VDS is increased, the drain current will remain 0 only. This is one definition for pinch off. And another definition is when VGS is equal to 0 and VDS is equal to VP, the current ID will become IDSS. The current will get saturated. Even if VDS is increased, the drain current will remain constant. So in this saturation region, voltage after pinch off, it acts like a constant current source. In cutoff region, when VGS voltage is equal to pinch off voltage, so drain current will become zero irrespective of value of VDS. So correct option is C. Next question. Compared to bipolar junction transistor, JFET has higher input impedance and lower voltage gain. So the input impedance of JFET is higher compared to the bipolar junction transistor, and BJT voltage gain is higher compared to junction field effect transistor. So let us see some more differences between BJT and FET. So BJT is a bipolar device having three terminals, that is emitter, base, collector. FET is a unipolar device having three terminals, drain, source and collector. BJT is a current control device. FET is a voltage control device. So that means in BJT, input current controls the output current. In FET, input voltage, that is gate voltage, source, drain and gate. So gate voltage controls the output current, that is drain current. Hence BJT is a current control device. FET is a voltage control device. This is gate. BJTs are more noisy, large in size and cheaper. FETs are less noisy because of no junctions and small size, costlier. The current in BJT is due to both majority as well as minority carriers, whereas current conduction in FET is due to only majority carriers. Hence, it is because it is a unipolar device. No thermal runaway in FET, and majority carry there is a thermal stability, whereas such kind of thermal stability is not possible with BJT. Input impedance is higher because leakage currents are zero and low voltage gain. So these are the points related to field effect transistor. Correct option is A. Next question. For class AB operation is dash operation similar to class A? Wrong, because the conduction angle efficiency and class AB so this efficiency of class AB is different from class A, and the conduction angle of class AB is different from class A B and class A power amplifier, and the cutoff point position for the Q point position in class A is exactly at the center of operating line, whereas on class B power amplifier it is on exactly on the middle of the load line. For class A, it is one end point in the cutoff region, that is x-axis, whereas in class AB operation cutoff point is just above the x-axis, Q point is just above the x-axis. So none of the above. So the operation of class A power amplifier doesn't matches with the any one of either with class A or class B or class C power amplifier. So correct option is D. Next question. So in this question, so these are the diagrams, conduction angles, waveforms of class A. So this is a waveform for class A, class B, class AB. Conduction angle is in between class A and class B, and this is class C. Conduction angle is less than 180 degrees, and the power amplifiers are classified into analog signal power amplifier. So that is class A, class B, AB, and C operation, and digital signal power amplifiers, class D, class E, and class F power amplifiers. So correct option is D. Next question. The ripple factor of full wave rectifier circuit compared to that of half wave rectifier circuit without filter. So generally the ripple factor without filter is, ripple factor is a measure of AC component in the rectifier output. So that is ripple factor gamma is equal to RMS value of AC component to average value or DC value. For half wave rectifier, ripple factor is 1.21. For full wave rectifier, ripple factor is 0.28. So correct option is B, less than that of half wave rectifier circuit. Ripple factor of full wave rectifier is less than that of half wave rectifier circuit. Next, when the capacitor is fully charged, when the current through the capacitor is same as current discharged. So this is a condition where capacitor is, we can say that capacitor is fully charged. When capacitor is fully charged, it reaches to the maximum value, maximum storage capacity, and further cannot accept any more charge. Therefore, no current flowing through it. This is because voltage across the capacitor is equal to voltage across the source, resulting no potential difference for the current flow. When capacitor is fully charged implies both voltages are same. Further, it cannot accommodate the charge, hence there is no flow of current. Therefore correct option is B. Next question. The saturation current of a transistor implies that. So generally for a transistor there are three regions of operation. One is cutoff region. So cutoff region means off switch. Transistor acts like a off switch. Active region. In the active region transistor acts like a amplifier. Next saturation region, transistor acts like a on switch. So in the question they have given saturation region. So it acts like a closed switch with negligible value of resistance. So correct option is C. Okay. The collector current is highest. When it is on switch means so current is highest. The collector current is peak. Collector current. So correct option is D. All options are correct. 1, 2, 3 are correct. Collector current. So on switch it means short circuit between emitter and collector. So short circuit means so current is maximum. Collector current is at peak. Collector current is maximum. If collector current is maximum is entire load voltage get entire voltage VCC gets dropped across a load resistor. So this is a all three statements are true related to the saturation condition. There is one more region, that is inverse active region. Fourth region of operation is inverse active region. In this inverse active region the transistor acts like a attenuator. In active region it is acting like a amplifier, that is emitter base junction forward bias, collector base junction reverse bias. So in saturation region both junctions are forward bias. So emitter base junction is forward bias, collector base junction is also forward bias. In cutoff region emitter base junction is reverse bias, and collector base junction is reverse bias. So correct option is D. So these are the points related to saturation region. Next question. The output of a particular op amp increases 8 volts in 12 microseconds. Then slew rate is. So the slew rate of op amp refers to maximum rate of change of its output voltage. The maximum rate of change of its output voltage. So that is how fast the op amp can change its output over a time. And the slew rate is measured in volts per microsecond. So slew rate is equal to change of output voltage within time. So 8 volt change in 12 microseconds time. So that is 8 by 12, 2 by 3, 0.666, 0.666 volt per microsecond. So correct option is B. Next question. With 0 volts on both inputs, op amp ideally should have an output. So ideal op amp output is 0 if input is 0. With 0 volts on both inputs, so that is a differential amplifier. If both inputs are 0 and the differential amplifier is ideal amplifier, so obviously the output is 0 volts. And let us see some features of ideal operational amplifier. Some characteristics of ideal operational amplifier: it has infinite input impedance, infinite bandwidth, zero output impedance, zero offset voltage, infinite slew rate, infinite common mode rejection ratio, and power supply rejection ratio is 0. These are the characteristics of ideal operational amplifier. Next question. Determine the output resistance of differential amplifier with three operational amplifiers. The op amp used is 741 IC with gain A is 2 into 10 power 5, and the output and the difference of input voltages are 44 and 11. The typical values for 741 operational amplifiers are: open loop gain is 2 into 10 power 5 and input resistance is 2 into 10 power 6 ohms. Output resistance is 75 ohms. These are the typical values for 741 operational amplifiers. And the question they have asked, the output resistance of differential amplifier is ROF is equal to RO by 1 plus AV by AD, output resistance with feedback. So that is, what is AV by AD? Output volt AV is 2 into 10 power 5 and AD is differential gain. AD is output voltage V0 by input voltage Vi, differential input voltage VID. So that is in the question, the output and difference of input voltages are 44 and 11 volts respectively. Its value is 4. Now ROF is RO, output impedance is 75 ohm by 1 plus open loop gain is 2 into 10 power 5 divided by 4. So its value is 1.5 into 10 power minus 3 ohms. So 1.5 milli ohms. So 1.5 milli ohm is very very less value. So it can also be written as 0.015 ohms. So this is a practical case. Ideally it can be treated as 0. So ideally output resistance or not can be treated as 0. 1.5 milli ohms. This is small m. It is should not be capital M. So capital M refers to mega. This is small m. Next question. The bandwidth of differential amplifier increases with when closed loop gain decreases. The bandwidth of differential amplifier decreases decreases if the value of closed loop gain increases, because the gain bandwidth product, it should be always a constant value. So correct option is B. If bandwidth increases, gain decreases. If gain increases, bandwidth decreases. In a differential amplifier configuration, the subtractor is called as difference amplifier. So correct option is D. So difference amplifier or subtractor, in this, output is equal to difference between the two input voltages applied to the inverting and the non-inverting terminals of operational amplifier, and it suppresses any common mode voltage or common mode signal. Correct option is D. Subtractor is called difference amplifier. So this is a circuit diagram for difference amplifier. So here R2 by R1 loop feedback resistor to input resistance. VIP is a voltage applied to non-inverting terminal and VIM is a voltage applied to the inverting input terminal. So output voltage is a function of input voltages as well as feedback and input resistor. Correct option is D. Next question. An ideal operational amplifier has. So the properties of ideal operational amplifier are: input impedance is infinity, output impedance is 0, bandwidth is infinity, 0 offset voltage, CMR common mode rejection ratio is infinity, slew rate is infinity, and power supply rejection ratio is 0. So correct option is D, all the above. Infinite bandwidth. So infinite bandwidth, input resistance Ri is infinity, R0 is 0, and input impedance Ri is infinity. All these three are the properties of ideal operational amplifier. Correct option is D. Next question. How many op-amp comparators should be chosen to get higher speed of operation? How is the op-amp comparator should be chosen? So this op-amp comparator should be chosen to have very wider bandwidth. So the bandwidth of operational amplifier comparator should be chosen to be wider, so that output of op-amp comparator can switch rapidly between two saturation levels because for comparator circuit the output is two levels, either plus V saturation or minus V saturation. To switch between these two output levels, plus V saturation and minus V saturation, the bandwidth should be chosen to have wider value, very wide bandwidth, so that op amp also responds instantly to the change in the condition at the input. So correct option is D, wider bandwidth. Next question. The gain of first order low pass filter. So first order filter gain decreases by minus 20 dB per decade or 6 dB per octave. Gain decreases by 20 dB per decade or 6 dB per octave. Low pass for a low pass filter, first order low pass filter. Next question. The poles of transfer function of normalized low pass Butterworth filter. So normalized low pass Butterworth filter exists in. The poles of Butterworth filter lie on a circle, whereas poles for the Chebyshev filter lie on a ellipse. This is the frequency response for the Butterworth filter, Chebyshev filter, elliptical and Bessel functions. So, so Chebyshev type 1 filter exhibit ripples in pass band. Chebyshev type 2 filter exhibit ripples in stop band. For same specifications, the order of Chebyshev filter is less compared to the Butterworth filter. So that is for same order, Butterworth filter require more number of components when compared to Chebyshev filter. The question, poles lie on a unit circle for Butterworth filter. Next few more points related to this filter is the transition bandwidth is more in Butterworth filter. The magnitude response of Butterworth filter decreases monotonically, whereas the frequency response monotonically as frequency increases, whereas the magnitude response of Chebyshev filter exhibit ripples in either passband or stopband depending on the type of a filter. Next question. A stable multivibrator operating at 150 Hz. So given frequency is 150 Hz. So from this time period T is equal to 1 by F, that is 1 by 150. Its value is 6.666 millisecond and the discharge time is 2.5 milliseconds. So let it be discharge time TD is 2.5 milliseconds. So from this duty cycle of the circuit is duty cycle, the discharge time by total time duration TD by T, 2.5 milliseconds by 6.666 milliseconds. Its value is 0.375. 37.5% is the duty cycle. Correct option is D. Calculate the output frequency in a frequency multiplier. So frequency multiplier is given. Frequency multiplier, its value is, let us assume the multiplication factor value is n. If input frequency is carrier frequency is fc, then output carrier frequency is nfc. If input frequency deviation is delta f, output carrier frequency is n delta f. If input modulation index beta, then output modulation index is n beta. So the frequency multiplier does not affect message signal frequency. It does not change the message signal frequency. If input message signal frequency is fm, the output message signal frequency is also fm. Therefore, if input frequency is 200 Hz, if input frequency given in the question, input frequency is 200 Hz, then what is the output frequency for a frequency multiplier of 7 divided by n network? So that is 7 times of input frequency 1400 Hz. So in the option it is 1.4 kilohertz. Correct option is C. Next question. Convert binary number into hexadecimal number. For the conversion of binary to hexadecimal, group 4 bits in the binary, that is 4 bits in the binary. So it starts from left hand side. Grouping starts from left hand side. Oh, these are the grouping of 4 bits, and convert this 4 bits in a group into a equivalent hexadecimal. So triple one in hexadecimal is equivalent to F. Triple one in hexadecimal is equivalent to F, and 0010. Its value is 2. So correct option is F2 base 16. This is a correct option. Its value is F, and its value is F, and its value is 2. FF2 base 16. Correct option is B. Next question. Which gate is best suited for is used as a basic comparator? So generally this XOR and XNOR gate can be used as comparators. So XOR gate is also called equality detector, whereas XNOR is equality detector, whereas XOR is inequality detector. From the table from the truth table, let us assume two input XOR gate or 0 0, two inputs, four combinations, 0 0 0 1 1 0 1 1. Its output is 0 1 1 0. So from the truth table of this XOR gate, if inputs are different, if inputs are complement to each other, then output is 1. If inputs are complement, output is 1. So that is inequality detector or anti-coincidence gate, or it is a staircase switch. So similarly, XNOR gate is equality detector. If both inputs are same, then it will detect the same inputs. XNOR gate detects the opposite inputs or complementary inputs. Next, even number of ones detector or coincidence gate. So both can be used as a comparator. Correct option is D. Next question. A decoder can be used as a demultiplexer by. So decoder with enable input can be used as a demultiplexer. Similarly, encoder with enable input can be used as a multiplexer. The decoder can be used as a demultiplexer by using input lines as data selection and enable line for data input. So correct option is D. So demultiplexer has single input, multiple outputs. Demultiplexer is a combinational logic circuit with single input, multiple outputs, having n selection lines. N selection lines. Whereas decoder consists of n input lines, 2 power n output lines, and single enable line. So the decoder can be used as a demultiplexer by using input lines as selection lines and enable input for the data input. Next question. A binary code that progresses such that only one bit changes between two successive codes is gray code. So gray code is a the correct answer is gray code, option A. So gray code is a unit distance code, that is only one bit changes between two successive codes or between two adjacent code words. It is a non-weighted code. It is a unit distance code. Gray code is a cyclic code with having reflective property. So in a gray code, two consecutive numbers differ by one bit only. This characteristic of one bit variation is used to minimize the errors during the transition, and is also used in rotatory encoder for accurate position detection. Correct answer is A. Next question. In mod 16, ripple counter is holding a count of 1001. What will be the count after 31 clock cycles? So given mod 16 ripple counter. So initial state is 1001. This is initial state. Initial state, and after 16 states, so it is a mod 16. After 16 clock cycles, it will again reaches to the same state, that is 1001. Again after 16 clock cycles, it reaches to 1001. So after 16 clock cycles, now there are total 32 clock cycles, and the prior value, the next value is 31st clock cycle is 1000. So this is the answer. So after 31 clock cycles, its value is 100. Correct option is A. Next question. Select the statement that best describes the read-only memory. So this read-only memory is a non-volatile memory. ROM is non-volatile memory used to store information that does not change during system operation. Whereas RAM, random access memory, is a volatile memory that loses its data when system is turned off. This is for permanent data storage. So even when the system is powered off, it doesn't loses its data. Whereas RAM, it is a volatile memory that loses data when the system is switched off. So correct option is B. So these are the first 50 questions of Kerala PSC 2017 question paper, part 1 solutions.